about Baily's beads. So we're going to ask Richard to share his screen. And Art, are you still sharing your screen? There we go.
Okay. I don't see my, here we go. Okay. We'll try to get this to full screen here. Okay. This talk is about a cell phone app that is available on the Google Play Store.
Richard, we're still seeing the PowerPoint window rather than the slideshow window.
Okay, let me try this again here.
Okay.
Start over. Okay, how's that?
Perfect.
And let me go to full screen. Okay. This talk is about an Eclipse calculator that's available for cell phones on the Google Play Store. It's called Eclipse Calculator 2. It is a full function Eclipse calculator. It calculates about every single parameter of an eclipse that you can think of and more, plus lunar eclipses, solar eclipses, and planetary transits. Its range of calculation covers from the years 1900 to 2100, expandable to the years 1550 to 2300. It has interactive maps for each type of eclipse, both solar eclipses, lunar eclipses, and planetary transits. And it's a free download for Android phones. It's approximately 23 megabytes in size. These are a couple of the screenshots from the app. I'm not going to go over all of these, but each image here that has a sliding bar on the bottom indicates that you have a animation for that particular event, such as a solar eclipse, a lunar eclipse on some of the bottom screens here. And in the far lower right-hand corner, there's a Venus transit, which we're all very excited about. Of course, the next one isn't going to go over 100 years from now. Okay, when you first turn on the program and you open it up, you get screen number 1, image number 1, and you can choose from solar eclipses, lunar eclipses, or planetary transits, or all of them. You can search by event down here on the bottom or by location. And once you pick one, you do compute, and then a screen appears. This is image number 3 on the right, and this is solar eclipses only. And you can scroll through this and cover solar eclipses for as long a time interval that you have chosen. Now, for this example on this talk, I've chosen the solar eclipse for Monday, April 2024. And we move down to image number 4, lower left of the screen. When you tap on this eclipse, you get this image here, and you can scroll through this image and get all kinds of parameters for the eclipse, contact times, eclipse limits, right ascension declination of the sun and moon, and so forth, even the delta T, which we know changes from year to year. And on the bottom of the screen, you have other options such as local circumstances, visibility, a map, and more. So on map, we move over to image number 5 for this particular eclipse. This eclipse occurs over the United States. It's a total eclipse, and this is a Google type map that you can expand on and shrink just like you would a picture on your cell phone, an image on your cell phone. Now I've zoomed in on near Austin, Texas here, which is located near the southern limit of the eclipse. And when you tap your finger on Austin, Texas, this window appears in image number 7, giving the details of this eclipse, the duration in seconds, the magnitude of the eclipse, the start and end times of totality, the greatest eclipse, and so forth. Okay, next screen. Now, image number 1 is the circumstances for the eclipse on April 2024. And this also displays the delta T, as you can see. Now, once we click on local circumstances, lower left-hand corner here, you have a range of countries that you can choose from and the cities that are pre-programmed into the app. Or you can choose your own location by entering a new set of coordinates using this button over here, if you can see my cursor. And then you tap on compute. So for Austin, Texas, just tapped on it. And next comes the screen. On the right-hand side, image number 4, this is the lunar limb profile, which is actually, you tap on the button down here. And it has an exaggerated profile of the moon at the bottom of the screen. This is the same exaggerated profile that Fred Espenek uses for his interactive Eclipse web pages. And there's a Baily's bead button. This is the key thing here. Tap on the Baily's bead button and you get the following. Well, why do we want to look at Baily's beads? Well, for IOTA's, this is the Baily's beads button. You get a new screen that allows you to slide your finger and simulate the Baily's beads along a time interval during second contact or third contact. And in this particular example, the time interval is about 16 seconds, and you can see how the Baily's beads change. This is the animated Baily's beads from the cell phone app. Very, very powerful program here. The next screen shows after totality has occurred. This is what we call third contact. And again, you slide your finger across the screen and the Baily's beads are coming back. Okay, you see how the pattern changes? This time interval here is about 15 seconds. Now, IOTA seeks to measure the Baily's beads in our long-term study to compute the diameter of the sun from one eclipse to the next, or historical eclipses. And this is the basis of the technique that is used. It's a skinny triangle. We want to measure the umbra on the ground, the width of the umbra, which is why we go to the path limits. And with a known distance to the moon and the sun and the known size of the moon, it's a simple matter to compute the diameter of the sun. Now, this is the basic idea of how we do it. It's not this easy, but this is the basic idea of what we're doing. Now, how does this Baily's bead app compare to our actual videos from eclipses? I and other people have been to some 12 Baily's beads expeditions for eclipses, and this particular one was from the island of Curacao for the eclipse of February 1998. Myself and Chuck Harold went to this site along with Wayne Warren, Aseo Sato from Japan, and others, and we measured the beads. This is before GPS time insertion in the WWV timing days. As you can see on my picture on the right, you see my WWV radio on the ground with the red arrow pointing to it, my telescope set up. And because I'm on an island next to the ocean, it was quite windy, so I set up this tarp with PVC to block the wind. It was quite useful. Now, without WWV, how do we compare the times to the cell phone app, which actually states the times to the 10th of a second? What I did for this demonstration is I played back my Baily's beads video on my computer, and I'm listening to the tones, and I would tap the print screen button on certain tones and write down that time. And with those times, I had video frames I could copy to make this comparison. So this is post totality. This is what we call second contact. And there are 2 beads formed off my video right here compared to the cell phone app. Excellent agreement. Now I'm going to scroll through these rather quickly. The next frame is 15 seconds later. There's 1 bead left. This is again before totality. And the next frame is about a minute later. This is after totality. And you can see the pattern of the beads from my video frame versus the cell phone app. We have very good agreement. Now, my video is a little bit overexposed, but you can see the shape of the beads and their sizes closely matches those of the cell phone app. This is a very powerful program. The next slide is about 7 seconds later. The beads are on the increase. Again, if you look at the left-hand bead here from my video, they're kind of merged together. And while they're not as easily sharp and resolved as the Baily's bead app, you can see the shape of my video very closely matches that of the cell phone app. It's an excellent agreement. And this is the last slide, I believe, of this eclipse. This is some 12 seconds later. Again, excellent match between the beads and the cell phone app. Okay, the next eclipse we tested was the August eclipse 2008 from China. Again, myself and Chuck Harrell traveled to China with a group of people to observe this eclipse. Most of the group went to the center line, and Chuck and I went to the southern limit. Now, this time in 2008, we had time inserted video. So you can see my video frame on the bottom. You've got the GPS time insertion on the video upside down. I'll read it. It's 11 hours, 9 minutes, 23.11 seconds. And on the video, we just advance frame by frame to get these times. We won't have an exact match with the cell phone app here, which is to the nearest 10th of a second. But to 100th of a second, that's pretty darn close. Now the beat pattern matches very well. And the next slide, again, this is pre-totality, before totality, second contact. This is a few seconds later, and you can see the bead pattern matches very closely. All right. Next one is 2 seconds after that. Again, the beads pattern matches. It's like an excellent match. The next frame, this is 3 seconds later. The beads are on the shrinking, getting smaller as we approach totality. Excellent match, including, if you can see my cursor, this small bead over here predicted by the app and the bead here on my video. Excellent agreement. And this is now a couple of seconds later. And then this next frame is 0.6 seconds after that. This is, again, just as totality begins. Now, following totality, here's the next frame. This is after totality is over, approximately 15, 20 seconds later. Again, the bead pattern is a very good match. And the next frame, excellent match also. This is the last frame for this particular eclipse. Okay. The next eclipse I compared was done by Joan and David Dunham. And this is the eclipse of July 2nd, 2019 in South America. Myself and Chuck Harrell went to Chile, right on the coast of the Pacific Ocean. And Joan and David Dunham stayed in Argentina at their hotel in San Juan. Okay, they were at the southern limit. This is the frames that David sent me to compare the cell phone app. And also he sent me his coordinates down here and his elevation. Now, as you can see, because this eclipse occurred near the sunset of the eclipse, the altitude of the sun was very low. At David and Joan's site, the altitude of the sun was 10 degrees. And along with their elevation of 628 meters, I had to do an elevation correction, which is what we used to do for grazers. So the elevation correction was applied, and I began comparing these 5 frames he sent me to the cell phone app, starting with this one in the upper left-hand corner. Here we go. 20 hours, 40 minutes, 3 seconds. David's video versus the cell phone app. Now you'll notice that David's video is a little bit blurry compared to my previous 2 videos. This is because of the low altitude of the sun and the seeing conditions. Next slide. This is 6 seconds later. Again, very good match, the cell phone app versus the video. You can see this is a very powerful program. Next slide is 4 seconds later. Okay. Next slide, excellent match here. Next slide is 11 seconds later. We're now getting close to totality. And the next slide is 11 seconds after that. This is the last slide he gave me. And then again, 1 small bead left over before totality. After totality, here's 3 more images from David's video. Again, very good, excellent match between the Baily Speed cell phone app and the actual video. So again, I'm stressing to you, this is a very powerful program. And the features of this program rival or match any internet website such as Fred Espenac, Javier Huber, and others. Okay, the next eclipse that occurs is going to be April 2023. It's mostly over the ocean, the Indian Ocean and Pacific Ocean. It does cross Australia at a point on the far northwest-hand corner at the place called Northwest Cape, excuse me. And actually at Northwest Cape, the path actually touches the land both the northern limit and southern limit. So if any of our Australian colleagues want to try this, this would be the place to do it. Turns out the weather prospects for April are pretty good for Australia in that location. The path also crosses Papua New Guinea and then goes out to the Pacific Ocean. This is not exactly the best eclipse to do the Baily Beach experiment. The next opportunity.
Hey, I got an idea. Look,
Yes. I heard a question.
watch now. See my picture in the corner there? Yeah. Right now. See if I had a blonde wig in my hand right now.
Okay. All right, continuing. The next opportunity for Baily's beads is going to be in 2023 October and 2024 April. These two eclipses, the annular in October 2023 and the total in 2024, cross the United States and America, as you can see the paths here. And the paths intersect over the great state of Texas. Here's the path of the annual eclipse over Texas. It crosses San Antonio. And 6 months later, the total eclipse in April of 2024 crosses Austin and San Antonio, Texas. Also Dallas-Fort Worth, which is above the screen here, out of the field of view. So these are excellent opportunities to do the Baily's Beads experiment. Now the red dot at the center of the screen is my house where I live. So obviously I'm very lucky living in the great state of Texas for these two eclipses. So this program, I've kind of gone through it rapidly, is such a powerful program for measuring, predicting Baily's beads at particular sites along with their contact times. And this is the last slide I have. So if there are no questions, I would pass it on to Roger.
Richard,
Any questions for
this
Richard?
is Ted. I just had one question. Do you have any idea whether the author of the program did any sort of comparisons like you have done to confirm that the app was going to be as accurate as you have found it to be?
Well, I've been in email contact with the author for several months. He's Eduard Bassana out of the University of Barcelona, and I sent him my comparisons a couple of months ago. I've sent him my YouTube videos of the eclipse. He was very impressed with the match, and I think I'm the first person to send him these videos for comparison.
Well, I'm here. I'm the author of the app. I'm Eduard Bassana, and I even very impressive with your work. I don't check before the match between the actual beats and the app. I have no opportunity because we have no videos, just some pictures that I took in some eclipses, but not from the Gracie song. So I think that this work is very, very impressive, even for me.
Yes, and the 3 videos I used to compare with Eduard's program, we had just about exact matches for every single video frame. I think Eduard, you're right on. I assume that you use the LRO data, Lunar Reconnaissance Orbiter, for your data to measure and compute the beads.
Is there an
Hey, Carol has
iPhone
a
version?
question.
Is there an iPhone version?
No, sorry about that, but this is a personal project that I did in my spare time, and I don't actually have more time to implement for iPhone. Sorry.
Dave Harold?
Yes, Eduard. Can I confirm that for the predictions, you've got a tables of the Basilian elements that you use, and they've been computed by presumably Fred Espinac?
Well, I compute the Basilian elements from the GPL. I think that 4.4 ephemerides, but I compute by myself the Basilian elements. I check it against the Fred Espinac elements, and they match. And then I compute all the local circumstance and general circumstance from those elements.
And the source of the lunar limb, what do you use for that?
Yes, it's the lunar orbiter laser altimeter from LRU instrument from the lunar reconnaissance orbiter.
Yeah. Everyone, I've just done a check of one of the predictions with from the cell phone with what I generate in Occult, and it's accurate.
Good.
Yeah.
Okay. Let's move on if we can. Thank you, Richard, for an excellent talk. I'm sure some of us will find that quite useful. Bob Anderson.